Let's review confidence intervals when population standard deviation is known. We use confidence intervals when we don't know the population average. It gives us a range of possible sample averages and tells us the percentage confidence that the population average falls within. So, if in our classroom we took a poll of 5 students in the class and found that the mean age in our sample is 27. We know our population standard deviation is 6. What is your range for each of the following? Construct a confidence interval that the population mean is likely to fall into. So at 95% confidence, what would our range be? So we need to use our formula, x bar plus minus ZA2, the population standard deviation for n. So here, our x bar is equal to the sample average ZA divided by 2 is equal to the z-score of the confidence interval this is the population standard deviation and our sample size. So let's enter this in here. We have 27 plus minus, now the z-score, we can use our probability table to show a 95% confidence or what we're looking for is a 0.9750. So what this would mean would be at a 5% less, we would have 2.5% on either side of it being either over or under. So these are pretty standard. You can also find the confidence intervals on your formula sheet here. So we can use 1.96. To better explain it, if we assume that we have a 95% confidence, that would leave a 2.5% chance the population mean will be lower than our range, and a 2.5% of chance that it will be higher than our range. So negative 1.96 and 1.96 would actually equal to a 95% confidence rate. .96. Our population standard deviation is 6 divided by our sample of 5. This equals 27 plus minus 5.26. So we can say that with a 95% confidence rate that the mean will be 27 plus minus 5.26, or 21.74 to 32.26. So with a 90% confidence, (27 plus minus) here in our formula sheet, 1.645. So we have a less of a confidence rate, meaning we are okay with being 10% wrong here. We're going to have our z-score of 1.645 multiplied 6 over square root of 5. That gives us a confidence interval of 27 plus minus 4.41. So that is less than our last one. The range on this would be 22.59 to 31.41. So as you can see, our total range is smaller than our range here. So we have less confidence that this is correct, so we have a smaller range. When we need more confidence, we'd have a larger range. So let's have a look what happens with 99% confidence. 27 plus minus, we can use the z-score, 2.576. And 6 divided by the square root of 5 equals 27 plus minus 6.91. So our range is 20.9 to 33.91. So with 99% confidence, we can be sure that the average age in our class is 20 years and 0.09 to 33.91. So a much larger range for a higher level of confidence. Now at 95% confidence, but with a sample size of 16, what will happen? (27) plus minus 1.96 standard deviation of 6 divided by the square root of 16. We get a confidence of 27 plus minus 2.94, or a range of 24.06 to 29.94. So as you can see, with a larger sample size, when we get a better representation of the population, it actually makes our range smaller because we have more information. So with 95% confidence with a sample size of 16, we have a plus minus of 2.94, or a range of about 6. With 95% confidence but a sample of 5, we have a range of 27 plus minus 5.25, with a range of about 10.5. So the larger the sample size, or the less confidence you have, will bring down the pardon me, we'll bring down the confidence interval. We'll bring down the range that is used.